So chapter 4.1, example 13, gives us this function y equals 1/2 x plus 3, and it asks us to graph it using the transformations. So with linear, if we want to look at this the way we've been looking at the other parent functions, this 1/2 would be our a value, which is our dilation factor, and then this plus 3 would be the k value because it's the vertical translation. So in this case, since since a is less than 1, then it's going to be compressed. And then the k is positive, so the graph is moved up. Another way we can look at this, since we're more familiar with the equation y equals mx plus b for linear equations, is that the slope m is 1/2, which means when you graph it, it's going to go over 2 and then up 1. That's our slope. And then the plus b, the b is 3 in this case, which means that the y-intercept is going to be 0, 3. So if we look at this on a graph, we see that the original function, the parent function y equals x, is graphed in red. And we have our original y-intercept, which is 0. And then the slope is going to be just a standard 1. Then we have the black line, which is a transformed graph, y equals 1/2 x plus 3. And in this case, the y-intercept is now up to 3, while the slope has been compressed since 1/2 is smaller than 1. So in general, if we're given a linear function and we want to transform it, then we have a, which is our dilation factor, and if a is greater than 1, it's going to be a steeper line. If a is a fraction, greater than 0, less than 1, then it's going to be compressed. And then we have k, which is our translation. It's also our y-intercept. And then if k is positive, then we go up. If k is negative, then we go down. It's a positive y-intercept, and this would give us a negative y-intercept. And one more thing to note would be if a is negative, less than 0, then the graph is going to go downward instead of the usual upward slope.